AFCI protection is mandated by code for all bedrooms. GFCI protection is generally required for receptacles in wet or damp locations such as bathrooms, kitchens, and outdoor areas. Bedrooms are typically not considered wet or damp locations. GFCI protection is not required for receptacles in this room. If GFCI receptacles are installed on an AFCI breaker, the GFCI devices will not function properly. AFCI breakers are designed to protect against electrical arcing faults, while GFCI devices protect against ground faults. These two types of protection are distinct, but having both in the same circuit can lead to nuisance tripping of the AFCI breaker. Therefore, it is best to avoid this configuration. AFCI protection is required in all bedrooms. GFCI protection is not required for bedrooms since they are not typically considered wet or damp locations. Do not install GFCI receptacles on an AFCI breaker, as it will interfere with the proper functioning of both devices. An arc fault circuit interrupter, or AFCI, is a type of circuit breaker that is designed to protect against electrical fires caused by arc faults. An arc fault is an unintentional electrical discharge that occurs when electricity jumps between two conductors. Arc faults can occur for a variety of reasons, such as damaged wiring, loose connections, or faulty appliances. When an arc fault occurs, it generates heat, which can ignite nearby flammable materials such as wood, paper, or fabric. AFCI breakers are designed to detect arc faults and trip the circuit, cutting off the flow of electricity and preventing a fire from starting. AFCI breakers work by monitoring the electrical current in the circuit. When an arc fault occurs, it creates a unique electrical signature that the AFCI breaker can detect. Once the AFCI breaker detects an arc fault, it trips the circuit, cutting off the flow of electricity. There are two main types of AFCI breakers, branch and combination. Branch AFCI breakers protect against arc faults that occur in the branch circuit wiring. Combination AFCI breakers protect against arc faults that occur in both the branch circuit wiring and the appliance cords that are plugged into the circuit. The National Electrical Code, or NEC, requires AFCI protection in many areas of the home, including bedrooms, family rooms, living rooms, dining rooms, and hallways. The NEC also requires AFCI protection for all 120-volt, single-phase, 15 and 20 amp circuits that supply outlets in these areas. A ground fault circuit interrupter, or GFCI, is a safety device that protects people from electrical shock. GFCIs are designed to detect ground faults, which occur when electricity takes an unintended path to ground. Ground faults can occur when a person comes into contact with a live electrical wire or a faulty appliance. When a ground fault occurs, electricity can flow through the person's body to ground, causing an electrical shock. GFCIs work by monitoring the electrical current in a circuit. If the GFCI detects a difference in the amount of current flowing into and out of the circuit, it assumes that a ground fault has occurred. Once the GFCI detects a ground fault, it trips the circuit, cutting off the flow of electricity and preventing an electrical shock. GFCIs are required in many areas of the home, including bathrooms, kitchens, garages, and outdoor areas. The NEC requires GFCI protection for all 120-volt, single-phase, 15 and 20 amp receptacles that are located in these areas. AFCI and GFCI breakers are both important safety devices that can help to protect people from electrical fires and electrical shocks. It is important to install these devices in accordance with the NEC and to test them regularly to ensure that they are working properly. When considering the electrical safety of a converted garage space now purposed as a bedroom, it is vital to understand the specific requirements for both AFCI and GFCI protection as outlined by the National Electrical Code. AFCI protection is primarily concerned with preventing electrical fires, while GFCI protection focuses on preventing electrical shocks. In a residential setting, bedrooms are specifically designated as areas requiring AFCI protection. This is because bedrooms often contain a high concentration of flammable materials such as bedding, clothing, and furniture, making them particularly susceptible to fire hazards caused by arcing faults in electrical wiring or appliances. An arcing fault occurs when electricity strays from its intended path and jumps between conductors, generating heat that can ignite nearby combustibles. AFCI breakers are designed to detect these arcing faults and quickly cut off the power supply to the affected circuit, thereby mitigating the risk of fire. GFCI protection, on the other hand, is typically required in locations where there is a higher risk of electrical shock, such as bathrooms, kitchens, and outdoor areas. These locations are characterized by the presence of water or moisture, which can significantly increase the likelihood of electricity flowing through a person's body to ground, resulting in a potentially lethal electrical shock. GFCI receptacles and breakers are designed to detect even small imbalances in the electrical current flowing through a circuit, indicating that a portion of the current is leaking to ground. When such an imbalance is detected, the GFCI device quickly trips the circuit, cutting off the power supply and preventing electrical shock. While bedrooms are not typically considered wet or damp locations, and therefore do not generally require GFCI protection, it is important to consider the specific characteristics of the converted garage space. If the garage floor is at grade level and susceptible to moisture or flooding, or if the bedroom will contain a sink or other water source, GFCI protection may be necessary to ensure electrical safety. In cases where both AFCI and GFCI protection are deemed necessary for a particular circuit, it is important to understand how these devices interact with each other. While AFCI and GFCI breakers do not directly interfere with each other's functionality, combining them on the same circuit can sometimes lead to nuisance tripping. This is because both types of breakers are designed to trip in response to specific types of electrical faults, and the presence of both devices in the same circuit can increase the likelihood of one or the other tripping unnecessarily. For example, a minor ground fault that would normally be handled by the GFCI breaker may also trigger the AFCI breaker, resulting in a complete power outage on the circuit. To minimize the risk of nuisance tripping, it is generally recommended to use a combination of AFCI/GFCI breaker, which is specifically designed to coordinate the functions of both types of protection. These combination breakers are engineered to distinguish between arcing faults and ground faults, and to trip only when the appropriate type of fault is detected. Another option is to separate the AFCI and GFCI protection onto separate circuits, if possible. This can help to isolate the effects of each type of fault and prevent nuisance tripping. Ultimately, the decision of whether to use separate AFCI and GFCI breakers, the combination AFCI/GFCI breaker, or to separate the protection onto separate circuits will depend on the specific characteristics of the electrical system and the requirements of the local electrical code. It is always best to consult with a qualified electrician to determine the most appropriate solution for a particular application. In addition to the requirements for AFCI and GFCI protection, there are several other electrical considerations to keep in mind when converting a garage space into a bedroom. Firstly, it is important to ensure that the existing electrical wiring in the garage is adequate to handle the increased electrical load of a bedroom. Bedrooms typically require more electrical outlets and lighting fixtures than garages, and the existing wiring may not be sufficient to support these additional loads. It may be necessary to upgrade the wiring to a larger gauge or to add additional circuits to accommodate the increased demand. Secondly, it is important to ensure that all electrical work is performed in accordance with the National Electrical Code and local electrical codes. This includes using the proper wiring methods, installing the correct types of electrical boxes and fittings, and properly grounding all electrical equipment. Failing to comply with electrical codes can result in serious electrical hazards, including electrical shock, fire, and property damage. Thirdly, it is important to obtain the necessary permits and inspections for all electrical work. Most jurisdictions require homeowners to obtain permits and inspections before performing any electrical work, including converting a garage into a bedroom. This is to ensure that the work is performed safely and in accordance with applicable codes. Finally, it is always best to hire a qualified electrician to perform any electrical work. Electrical work can be dangerous, and it is important to have it performed by someone who is properly trained and experienced. A qualified electrician will be able to assess the electrical needs of the converted garage space, design an appropriate electrical system, and perform the work safely and in accordance with all applicable codes. In summary, when converting a garage space into a bedroom, it is essential to understand the specific requirements for AFCI and GFCI protection, as well as other electrical considerations. AFCI protection is typically required for bedrooms to prevent electrical fires, while GFCI protection may be necessary if the bedroom is susceptible to moisture or flooding. Combining AFCI and GFCI protection on the same circuit can sometimes lead to nuisance tripping, so it is important to consider the use of combination AFCI/GFCI breakers or separating the protection onto separate circuits. Additionally, it is important to ensure that the existing electrical wiring is adequate to handle the increased electrical load of a bedroom, that all electrical work is performed in accordance with the National Electrical Code and local electrical codes, and that the necessary permits and inspections are obtained. Ultimately, it is always best to hire a qualified electrician to perform any electrical work to ensure that it is done safely and in accordance with all applicable codes. The National Electrical Code, or NEC, provides specific guidelines for electrical installations in residential, commercial, and industrial settings. These guidelines are intended to ensure the safety of people and property by minimizing the risk of electrical shock, fire, and other hazards. Article 210 of the NEC covers branch circuits, which are the circuits that supply power to outlets, lighting fixtures, and other electrical equipment. This article specifies the requirements for the number and type of branch circuits that are required in different areas of a building, as well as the requirements for the overcurrent protection of these circuits. Article 210.12 of the NEC requires AFCI protection for all 120-volt, single-phase, 15 and 20 amp branch circuits that supply outlets in dwelling units. This includes circuits that supply outlets in bedrooms, family rooms, living rooms, dining rooms, and hallways. The purpose of this requirement is to protect against electrical fires caused by arcing faults in electrical wiring or appliances. Article 210.8 of the NEC requires GFCI protection for all 120-volt single-phase, 15 and 20 amp receptacles that are located in certain areas of dwelling units. This includes receptacles that are located in bathrooms, kitchens, garages, and outdoor areas. The purpose of this requirement is to protect against electrical shock caused by ground faults. Article 406 of the NEC covers receptacles, cord connectors, and attachment plugs. This article specifies the requirements for the type and location of receptacles that are required in different areas of a building. For example, Article 406.9 requires that all receptacles that are installed in wet or damp locations be listed as weather resistant. Article 408 of the NEC covers switchboards and panel boards. This article specifies the requirements for the construction, installation, and overcurrent protection of switchboards and panel boards. A switchboard is a large electrical panel that is used to distribute power to multiple branch circuits. A panel board is a smaller electrical panel that is used to distribute power to a limited number of branch circuits. The NEC also contains specific requirements for the installation of electrical wiring. Article 300 of the NEC covers wiring methods. This article specifies the types of wiring that are permitted in different applications, as well as the requirements for the installation of this wiring. For example, Article 310.15 specifies the ampacity of conductors, which is the maximum amount of current that a conductor can carry safely. Article 314 of the NEC covers outlet boxes, device boxes, and conduit bodies. This article specifies the requirements for the construction, installation, and support of these boxes and bodies. Outlet boxes are used to enclose electrical connections at outlets and switches. Device boxes are used to enclose electrical connections at lighting fixtures and other electrical devices. Conduit bodies are used to connect sections of conduit. In addition to the NEC, many local jurisdictions have their own electrical codes that must be followed. These codes may be more stringent than the NEC in some areas. It is important to consult with a qualified electrician to determine the specific electrical code requirements that apply to a particular project. When planning an electrical installation, it is important to consider the following factors: the electrical load, The electrical load is the amount of power that will be used by the electrical equipment that will be connected to the electrical system. It is important to calculate the electrical load accurately to ensure that the electrical system is sized properly. The voltage. The voltage is the electrical potential difference between 2 points in an electrical circuit. In the United States, most residential electrical systems operate at 120 volts or 240 volts. The amperage. The amperage is the amount of electrical current that is flowing through an electrical circuit. It is important to select conductors and overcurrent protection devices that are rated for the amperage of the circuit. The wiring method. The wiring method is the type of wiring that will be used to connect the electrical equipment to the electrical system. The wiring method must be appropriate for the application and must comply with the requirements of the NEC. The overcurrent protection. The overcurrent protection is the device that is used to protect the electrical system from overcurrents. Overcurrents can be caused by short circuits, ground faults, or overloads. It is important to select overcurrent protection devices that are rated for the amperage of the circuit and that comply with the requirements of the NEC. By considering these factors, it is possible to design an electrical system that is safe, reliable, and compliant with all applicable codes. When working with electricity, it is important to take certain precautions to protect yourself from electrical shock and other hazards. Always turn off the power to the circuit before working on any electrical equipment. Use insulated tools when working with electricity. Never work on electrical equipment when you are wet or standing in water. Wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Electrical work can be dangerous, and it is important to take the necessary precautions to protect yourself.